This is my Momentum or Egg Lab by Drew Fairby. Miss Smithy, this rose, I give this to you. I want you to sit back, relax, and enjoy these physics that I'm about to talk about in this video. Let's get into the introduction. I have placed some physics memes on each title card, so there you go. One of the main concepts addressed throughout the lab report is momentum. This is the property of an object in motion. It measures an object's tendency to move at a constant speed along a straight path. Momentum depends on speed and mass, which is represented by the formula P equals mv. To calculate the momentum of a moving object, you multiply the mass of the object times its velocity. Momentum is a vector, which means that momentum is a quantity that has a magnitude or size in a different direction. Another main concept discussed throughout the lab report is impulse. Impulse and momentum play hand in hand, but while the momentum of an object is calculated as the product of mass and velocity, the impulse represents the change of momentum of a system over a certain period of time. One of the reasons why impulse is so important is because in the real world, forces are not constant, or they often are constant. The concept of impulse that is both external and internal is fundamental to understanding the conservation of momentum. The main concept behind these properties, which we previously stated, momentum and impulse, is the impulse-momentum theorem, as stated in the name. The impulse-momentum theorem states that the change in momentum of an object equals the impulse applied to it. This theorem can be expressed by the equation force times time equals mass times change in velocity. So this is the main thing used to protect our egg and figure out a way to decrease the overall force by increasing the time, which will lower the acceleration. Our task was to build a contraption that would prevent the egg from breaking when dropped from a certain height. The egg had to survive an 11-meter drop off of a bridge. We have to use the previously listed concepts, impulse, momentum, the impulse-momentum theorem, to design a contraption that will protect the egg. By conducting this experiment, we would be able to find the different factors that would affect an object's momentum and the force when it collides with another object. We will now be discussing the experimental aspects of the lab. I'll give you a little bit to look at this meme. Appreciate it. Okay, on to the next thing. The construction process. We were given $20 to spend on materials. Miss Smithy did this, I would assume, to limit the amount of resources used. With our group's total of $20, we bought 5 pieces of foam, masking tape, hot glue, and 4 straws. We began by building a box with the foam pieces to place our egg in. Since we only had 5 pieces of foam, we built a box without a top. We would later use tape to cover the top. We hot glued and taped the pieces together to form the box. After that, we secured our egg by constructing a hammock-like structure out of tape. This is the hammock we constructed. We did this with the intentions of the bottom hitting the ground, if it flipped over and hit the top, Eduardo's down, but we were trying to increase the amount of time it would take for the impact to hit Eduardo. Obviously, just the hammock alone would not have done the job. We would have put tape on top of it, not just left him hanging, but we needed to increase the time or decrease the impact velocity, so we incorporated new features with those purposes. The first of these features were balls of stuffed tape, which we put in the empty space beneath the hammock, and we added this to try and absorb some of the impact and reduce the total force placed on Eduardo. This is the multiple balls of tape we placed. It kind of looks like a womb, but it was under it. That's going to absorb some force. The final feature and most effective feature we added were wing-like flaps on each side of the box. This provided air resistance and increased the total amount of time. This was super useful because increasing the time would lower the velocity and therefore lower the acceleration. And we did this by constructing the wings by gluing a straw on each side of the box. Then we used tape connected to each straw and continued this process until we had sturdy wings. These are the wings that we added, and we tested this addition by dropping it from our shoulders and seeing the resistance that it provided. Eduardo was not in this while we did this, but it was a very noticeable improvement. Results and discussion. I know you're smart, Miss Smithy. You can understand this meme. Yup. Okay, so how much force is required to break an egg? So when a collision occurs, momentum will be transferred to the other objects. Before conducting this experiment, we had to find the amount of force required to break an egg. We needed to make sure that the force didn't exceed the amount of force it takes, which we found by multiplying the egg's mass by gravity. The mass, 1.47 kilograms multiplied by gravity, 9.8, gave a total force of 14.4 newtons. Knowing this, we were able to use those features that we knew would help decrease the force of impact by increasing the time and cushioning the impact. How fast will Eduardo be going before impact? Another necessary factor used to successfully protect the egg is velocity to impact. In order to find this, we had to use the third kinematic equation as shown below. And using the final velocity, we knew what our egg needed to be able to withstand. So we know that with momentum, the same force is applied onto the object when impact happens. So when we decrease the acceleration by adding those wings, which would increase the time, we came to the conclusion that our reduced acceleration would reduce the force applied on the egg as well. Hold on! The video you just saw was indeed the moment of truth, Eduardo's free fall. Throughout the drop, we observed many factors, the most prominent being the efficiency of the wings. The time extension caused by the wings lowered the acceleration and ultimately saved Eduardo. This was the impulse momentum theorem. The theorem states that momentum will be transferred into an object when the collision occurs, making the force equal on both objects, in this case Eduardo and the Earth. So since we successfully decreased the acceleration, decreasing the momentum, the overall force transferred back into Eduardo was decreased, which was lower than the force it takes to crack an egg. I think that we were successful because obviously the egg didn't crack, but we successfully found a way to lower the 14.4 newtons required to crack an egg and save Eduardo's life by using the velocity an egg from that height of 11 meters would be. We constructed an apparatus that would protect our egg. Similar to the egg drop, engineers use features such as airbags and a car's crumple zone to reduce the damage/force received. The crumple zone increases the time taken to change the momentum of the driver and passengers in a crash, which reduces the force involved. Airbags increase the time taken for the head's momentum to reach zero and so reduce the forces on it. They also act as a soft cushion and prevents cuts. Now it is time to conclude this lab report. And this meme, I feel like, relates to you a lot, Miss Smithy, because you would definitely push me off a bridge. A building. Concluding the report. Our goal of dropping the egg without it breaking was met through the application of momentum, impulse, and reducing the force by slowing down its acceleration. It would be justified to claim that our experiment was successful and fulfilled its purpose because our contraption both protected our egg and slowed down the acceleration. The purpose of the experiment was to understand the properties incorporated with momentum and successfully apply those properties. We succeeded in doing that and protected our egg in the outcome. I can improve the experiment by testing other variables such as different surfaces or change the materials to see how that affects the force received.